Hello everyone again. We continue with the correction of our exercises. We are on the lesson number 5, alternative structure or loops. We are going to correct all the exercises that we have done so far. Okay, this is the question number 1. It says, write an algorithm that asks the user for a number between 1 and 3 until the suitable answer is given. So, as long as the number that is given it is not between 1 and 3, the program will keep repeat itself. Let's do that. We are going to declare a variable that will store that number as integer. We are going to start our program. We are going to write enter a number between 1 and 3 and 3. You're going to read and now while the n entered is less than 1 or n is greater than 3. I think we need to put our read inside the loop, not necessarily here. Not necessarily here. Then if n is less than 1 or n is greater than 3, then write wrong entry, repeat, and we're going to end our if. We're going to end our while. We need to arrange the code in a way that it will be organized. We end our while and we end our program. As you can see, the start is on the same line with the end, the while on the same line with the end while, the if in the same line with the and if. Okay, we go on the second exercise. We are going on the second question, which is write an algorithm that requests a number between 10 and 20 until the answer is suitable. If the response is greater than 20, a message will appear smaller, and vice versa, bigger, if the number is less than 10. We are going for that algorithm. Number 2. We are going to declare a variable let's say n and I as integers, and we are going to start our program, and going to write enter a number. We are going to read that number, and then maybe let's read after we have done the loop. While n, it has the same logic like the first question, is less than 10, or n is greater than 20, then let us arrange it in a nice way. I'm going to read n, we read n, and after we read n, we are going to say if the n entered is less than 10, or n entered is greater than 20, then we are going to display a message we are going to display bigger. Let's limit ourselves first on when it is less than 10. Bigger. Okay. Then else if, the same else if n is greater than 20, okay, and then we are going to display smaller. And then we are going to end our if, and if we are going to end our while, and then we are going to end our program. This is it. So let's go to the question number 3. Number 3. What is the question? Write an algorithm which requests a starting number and which then display the next 10 numbers. For example, if the user enters 17, the program will display the number from 18 to 27. Okay. Okay, so we do it. We are going to declare a variable on this question number 2. I think we declare a variable of which we really don't need. I think we need like to remove I because we don't need it, and remain only with n. And remain only with n. Number 3, we are going to declare a variable n, and we are going to need I as integer, and we are going to start our program, and write enter number. We are going to read n, and then let's say we should have declared another variable. Let's call it stop, something like that, to help us stop our loop. And then we say the stop will receive n plus 10 plus 10. So if, for example, I put 3, stop will immediately get 13, and when it will start to display from n to 13 number, so we will display what we want to display. And then we write the following 10 numbers are and then we are going to write while n is less than 10. Okay, what, not n, I, excuse me, I will be less than 10. I will be incrementing I plus 1. It will be, excuse me, I think something is wrong here. I said while n is less than 10, excuse me, this n will be receiving n plus 1, n plus 1. We'll be receiving n plus 1, and then we display the n. Write n. We end our while, and we end our program. So there is no need of I, because we didn't need it. That's all for this program. It can answer to our problem. Let's go to exercise number 4. The exercise number 4 says write the previous algorithm. This time we are going to use for loop. We are going to use for loop. Okay. Let's go. We are going to declare a variable excuse me again. I think here we need it to not only display n, it has to display I think it's okay. This one is okay, but let's go to the exercise number 4, and from here we are going now to use the for loop. We are going to declare a variable n I as integer, and then we are going to start our program, and we are going to write enter a number. We are going to read n, and then write enter the following 10 numbers are for I that will start from n plus 1, n plus 1 to 2 to n plus 10. That means if, for example, n is 6, it will start from n plus 1. That means 7 to 17, because n plus n, since n it is 7, and 10 plus 10 it will be 17. And what it will be doing, right, I next, and this is it. Okay, we go to the fifth exercise, and write an algorithm which requests a starting number and which then writes the multiplication table of this number, presented as follow. Case where the user entered the number 7. Okay, the table will be this way. Okay, let's do it. We have a variable. We'll need a variable n and I as a integer, and then we start our program, and we are going to write enter a number. We are going to read n and write the multiplication table of is the multiplication table is for I that will start for 1 to 10, right? Let's start with n time I equal n times I next, and end of our program. This is it. We go to the fifth exercise. The fifth exercise. Oh, the sixth, I think. Yeah, the sixth. Number 6. What is it? Write an algorithm which requests a starting number and which calculates the sum of the integers up to this number. For example, if you enter 5, the program must calculate 1 plus 2 plus 3 plus 4 plus 5. that equal to 15. This is what you're going to do. And to do that, we are going to declare a variable, let's say n, I, and sum as integers, and we start our program. By starting our program, we are going to write enter a number. We are going to read the number, and then our sum is going to be initialized by 0, and then for I that will start from 1 to n, the sum will be receiving sum plus I next, right? The summation is the sum that has been calculated, and then we end our program. This is number 6. Let's go to the program number 7. The program number 7 says write an algorithm which require a starting number and which calculate its factorial. Note the factorial of 8 noted like 8 and the exclamation mark is worth 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. This is how the factorial is found. So from here we will also declare a variable n. We'll declare another variable I, another variable f as integers, and we are going to start our program and write enter a number. We are going to read n, and we are going to say the factorial. We are going to initialize it first with 1. Every time it's about the factorial, you have to initialize by 1. If you put 0, you know every number that will be multiply itself to 0, it will be rendering that number to be null. So it's better to start with 1. And we open our loop for I that will start from 1, maybe let's say from 2 to n that has been entered. Okay, the factorial, it will be f times I next. Right. The factorial of the number is f. We end our program. This what will help us. We are going for the 8th question. For the 8th question. For the 8th question, we read write an algorithm which successively requests 20 numbers from the user and which then tells him which was the largest among these 20 numbers. For example, it will be making enter number 1 up to 20 and the user will be putting numbers. And then in the end, it will tell him, okay, this algorithm, the largest number has been found in this area. Okay? And then they say, then we are going to modify the algorithm so that the program also display in which position this number was entered. And for example, it was entered on number 2. Let's do it. We are going, this is number 8, variable n, and then we are going to declare the variable n, the variable I, and the variable large as integers, and then we are going to start our program. We are going to assume from now that the large number is 0. Then we start our loop for I that will start from 1 to 20 right? Enter a number, and then we enter a number. That number will be, let's say, any number. Read n, and then we are going to set a condition. Yes, if I equal to 1 or n is greater than large, then the large number will receive n. We end our if I next, and we end our program. So I think will solve our problem. And then we were asked to modify to make sure it will only we didn't display the largest number. We're going to write let's say write the largest number. The largest number is L. Suppose they said, okay, we need to modify it. Not only we will need the largest number, but also the position of the largest number. Okay, and let's declare it. This variable, let's say PL. For it is the same question, but we want also to add the position of the largest number. And if we put it there, well, here largest number will be receiving, but the position large will be receiving I. Will be receiving I. And from here we can say write position largest number is PL. As you can see, we solve our problem. Not only the program will display the largest number, it will also display the position of that largest number, if it was entered the second, the third, or the fourth. Okay, so we go to the ninth question. The ninth question. What does it say? Write the previous algorithm, but this time we do not know in advance how much the user wants to enter the number. Number entry stop when the user enter 0. Okay. So as long as the user don't put 0, the program will keep ask him to do what? To enter a number. I think here we'll use what? The while loop. Let's do it. We are going to declare number 9. We're going to variable n I large number and position large as integer. Then we start our program. We are going to initialize n by 1. We are also going to initialize I by 0. We are going also to initialize L by 0 2. Then we open our loop, our while loop. While n is different with 0, what must happen? We are going to display, right, enter a number, then we read n, and I will receive I plus 1. Then if I equal to 1 or n is greater than large, then large will receive n, and position large will receive I. Will receive I. Then we end our if, then we end while. From here we are going to have to display the position, right? The largest number is L, right? The position of largest number is position large. Then we end our program. Thank you very much. I think this is the end of the correction of this exercise. God bless you.